One of the things we have to do during this define phase is to very objectively identify what are the measurable components of the problems and the defects and the issues that we're facing. To do this, we're going to define terms called an operational definition. Now, operational definitions, they were first created in the 1920s, but their history actually goes back to the 1880s. At that point in time, one of the discussions was, how do we clearly define the distinction between the labels we use for numbers and the numbers? How do we create that relationship? In 1923, a man named Percy Bridgman wrote a book, The Logic of Modern Physics, and he was the one who defined operational definitions. And what he said is an operational definition is a precise description that says how we align a quality characteristic, what we name it, with a particular measurement system. And the idea is we want to have logical subgroups created of the problems or the products and so forth, and then put those into terms that can be objectively analyzed with empirical data. So the idea is what we're going to do is we're going to remove ambiguity. So anybody who's interpreting the term will have the same understanding using common language about what we mean by it. So it has to identify clearly what are we measuring, maybe the limits of measurement, and assure that the results then and how we deal with that are actually measurable and reproducible as we go from one measurement system to another, or as different people start taking the same measurements. Interestingly enough, Bridgman related this back to the work of Albert Einstein. And Einstein was saying, you know, if I had to spend all of my life or 1 hour of my life trying to solve the problem of how do we fix something in the universe, he says, I would spend 55 minutes of that hour defining the problem, and then only the last 5 minutes working on the solution. So the idea that comes out of this is it's very important to spend our time really understanding the problem, not just going off and trying to identify it. So one of the problems that we have with operational definition, for instance, if we talk about how do we score a goal in football? If you tell me, I say, oh, you throw the ball to a man and he goes over the line, and you say, you're crazy, you have to kick it into the goalpost. What do we mean by football? I'm clearly an American, so I mean American football. You may be a European student of industrial engineering, and you clearly mean what I would call soccer. And so as we take a look at this, what are the rules of the game? How do we play it? If I looked at football, you know, football could be soccer, it could be American football, it could be indoor football, Gaelic rules football, UK football, Australian rules football, indoor football, and they all have different rules. So how do we actually understand how we're going to play the game? The way we do it is we specify the rules, the conditions under which we operate and how we collaborate. What are the boundary conditions in terms of what can be done and what can't be done? And this is what we want to do with an operational definition. So for instance, if I'm going to talk about on-time delivery, what do I mean by on-time delivery? Is it something that starts here when I finish it at the end of my production line and it ends when you actually got it in your hands as a customer? Does it include the transportation stuff over which I have no responsibility? Does it include also any types of problems that may happen on the way? What is actually included in this? Is it also included no matter where you use it? Perhaps you haven't implemented it yet, so you haven't quite actually seen a delivery in terms of a usable product. So many times people will buy a product and put it on storage waiting for the time to use it. So what do we actually mean by on-time delivery? When the customer requests the date, it may be very different than when I acknowledge the date. So what was the starting point? And start taking a look, something as simple as on-time delivery may have lots of different things. And if what we say is on-time delivery means delivery on expected date at reasonable transportation cost, well, that sounds good, but what do we mean by transportation cost? What is reasonable? What is unreasonable? And you start seeing all of a sudden these words are kind of loose. So the problem that we want to have in an operational definition is when we say we want to do something, how do we specify exactly what we mean by it? And what are going to be the conditions by which we then test that? Because operational definition should be used for the definition of the problem. It should be used for how we measure the problem. It should be used for the defects. So many times if we see in an organization, we see lots of people saying, the defect is this. Or particularly in a telephone communication system, in a call center. Different people are saying, I'm going to code the defect this way. Somebody else codes it a different way. And the next thing we know is we've confused all of the data because people are not anticipating how they actually evaluate that information that came to them verbally in their ears and how they transition that into data that's going to go into a measurement system. So we're going to come back and we're going to look at this because particularly at the greenbelt level, we see this happening because people in a process may have their own view on how they want to take a look at these things. And one of the things we need to do is calibrate those people so that when they have an experience, they record their experience using the same terms and assign it the same type of data. Then we don't have data measurement errors clouding up the analysis in terms of what we have. So we'll come back and we'll talk about using something called attribute agreement analysis as a methodology to clarify how operational definitions are actually put into practice in a process.